In this video, we'll be going through question 11 from the 2021 HSC Mathematics Extension 1 exam, and this will be the second in a series of 5 videos covering the entire paper. So the first part A, find I plus 6j plus 2i minus 7j. So this is really quite straightforward. We just add component-wise. So these are our two vectors, and we add the I components together and the j components together. It's essentially like we're collecting like terms with algebra. So we get 3i plus 5j. 1 mark. Part B. Expand and simplify 2a minus b to the power 4. Okay, so here we want to expand 2a minus b to the power 4. And this looks like a binomial expansion. So you could really do this in a couple of ways. You could just physically expand this out, which would be a little bit tedious, but it still would work. You could use Pascal's triangle, or you could try to actually use the binomial theorem. I'm going to try to use the binomial theorem here. And so that means if I write it in my sigma form, I'm summing from k equal to 0 up to 4. I have to have my binomial coefficient. So I'll have 4 choose k. And then my first term, which is 2 to the a being raised to the power of 4 minus k, and then my second term, which is negative b, gets raised to the power of k. And now all I have to do is run through the values of k from 0 up to 4. So we get 4 choose 0 times 2 to the a, 2 times a to the power 4. This will be to the power 0, so that's just 1. Then we have plus 4 choose 1, 2 to the a cubed, negative b to the 1, plus 4 choose 2, 2 to the a squared, negative b squared, plus 4 choose 3, 2 to the a times negative b cubed, plus 4 choose 4. Then we'll have negative b to the power 4. Of course, 2 to the a, 2 times a to the 0 would be 1. So we don't really need to include it. Now, what's the sort of pattern that's going on here? Well, every second term, the terms in which minus b has an odd power, so it's these two terms here, it's going to end up being a negative because we're raising a negative to an odd power. And then we just expand and simplify. So the constant here would be 1 times 2 to the 4, which is 16. So 16a to the 4. Then, as we said, we have a minus. Our constant would be 4 times 2 cubed. So 4 times 8, 32, a cubed b. Plus our constant here is 6 times 2 squared. So 6 times 4 is 24. And then minus 4 times 2, that's 8, ab cubed. And then finally plus b to the 4. And then we have it expanded and everything is simplified. Great, and let's move to the next one. Question C. Use the substitution u equals x plus 1 to find the integral of x times the square root of x plus 1. So x times the square root of x plus 1 dx. Now, you might know a little trick in order to do this without a substitution, but we're told to use the substitution, so we don't have a choice. We have to use it. So on the side, we'll say u is equal to x plus 1. Then we need to differentiate to get our differentials correct. So du on dx is equal to 1, and so du equals dx. This is an indefinite integral, and so we don't need to concern ourselves with changing any limits. Okay. Now we go ahead and we substitute in everything that we have. So we have the integral of x. Now, whoops, this integral, the laser's not popping up. This x here, I need to rearrange this in order to make x the subject. It's not hard to do. We get x equal to u minus 1, and now I can sub in u minus 1 for x. So, whoops, u minus 1 times the square root of x plus 1, but now we're saying that that's the square root of u, and dx is equal to du, and so we have a du there. Now this is a little bit easier to deal with because we can distribute or expand through this bracket, distribute it through these two terms. I don't know why my laser's not picking up. And we'll get some terms to integrate. So we'll get u to the power of 3/2, because that's u times root u, and then minus u to the half. And notice that I wrote it with an index straight away because I'm anticipating the fact that I need to integrate, and having it written in that form where I have a power instead of a radical sign just makes it easier for me to integrate. Okay, we get u to the 5/2. We're adding 1 to the power and we divide by that new power. Once again, add 1 to the power and divide by the new power. And of course, we need a plus c because this is an indefinite integral. I will tidy up those fractions in the denominator, flip them and multiply by them. So that'll be 2/5 u to the 5/2 minus 2/3 u to the 3/2 plus c. And we need to make sure now to back substitute for our original variable, which was x, okay? So now we use this substitution and plug it back in to these two terms. So we have 2/5 x plus 1 to the 5/2 power minus 2/3 x plus 1 to the 3/2 power, and of course, plus c. And that's the end of part C. Now, question D says, a committee containing 5 men and 3 women is to be formed from a group of 10 men and 8 women. In how many different ways can the committee be formed? Okay, so we've got a total of 10 men and 8 women, and we would like the committee that we're choosing to have 5 men and 3 women. So if I've got to choose 5 men, I've got a total of 10 to choose from. So the number of ways that this can be done is in 10 choose 5 ways. And then I need to multiply that by, I need to choose 3 women from 8. So 8 choose 3. And then plugging that into the calculator, you get 14,112 as your answer. So there's 14,112 ways of creating that committee. All right, the next part. Part E. A spherical ball is moving up through a liquid. As it rises, the bubble gets bigger and its radius increases at the rate of 0.2 millimeters per second. At what rate is the volume of the bubble increasing when its radius reaches 0.6 millimeters? Express your answer in millimeters or in cubic millimeters per second, rounded to 1 decimal place. Okay, so as I'm reading a question like this, I always like to try to note down the information that's given to me as I'm going through it. So I'm actually going to go up to the question and show you how I would do that as I read through the question. So we've got a spherical bubble moving through a liquid. As it rises, the bubble gets bigger and its radius increases at a rate of 0.2 millimeters per second. So here I know that the rate of change of the radius, dr on dt, is 0.2 millimeters per second. And I know that it's positive because the radius is increasing. Okay, if it was decreasing at that rate, I would have to have a negative sign. Now the next part says, at what rate is the volume of the bubble increasing? So what we're doing is we're looking for the rate at which the volume is increasing. So actually I'm looking for dv on dt. What is that equal to? Maybe I'll use a capital V for volume. So what is that equal to when the radius is 0.6 millimeters? So when r is equal to 0.6, what is the volume? Okay, and that's how I'm analyzing a question like that. Okay, so let's go down, write that information. We have that dr on dt was equal to 0.2, and what we want is dv on dt when the radius is 0.6 millimeters. What's that? Okay, so this obviously now looks like it is some sort of related rates question because we've got a rate here and we want to try to relate it to this rate here. And so we're going to want to use our chain rule. So dv on dt. I know that I've got a dr on dt here. And so what's really kind of missing is I need to get a dv on dr. And so the question is, well, how do I find what this is? Well, since I know that this is a spherical bubble, I can write an equation which relates the volume to the radius. Okay, so that's simply the the equation for the volume of a sphere. So I would say something like, for a sphere, we have that the volume is equal to 4/3 pi r cubed. I believe that's on the formula sheet or the reference sheet, but it is something you should just know from your junior years. And we want to find dv on dr. So if we differentiate this, dv on, choose a capital V, dv on dr is equal to 4 pi r squared. And then when we have r equal to 0.6, dv on dr is 4 times pi times 0.6 squared. Okay, plugging that into a calculator gives 4 times pi times 0.6 squared, 4.5238 ... I would not round off there, I would leave it like that, and I would leave it sitting in my calculator as well, because now I can say that dv on dt equals, I'm probably just going to rewrite this one more time, dv on dr times dr on dt, and then I'm able to say when r is equal to 0.6, the rate of change of the volume is 4.5238 ... multiplied by dr on dt, but we know from the question that's always 0.2, that's staying as a constant. And now I can just press answer times 0.2 on my calculator and get 0.904. And the question asks for it to one decimal place, so we get 0.9 cubic millimeters per second. Okay, and that's the end of that question. Now part F says to evaluate the integral from 0 to root 3 of 1 over the square root of 4 minus x squared dx. So let's write it down. The integral from 0 to root 3, 1 over the square root of 4 minus x squared dx. Okay, so this, if I'm looking at this, I see that it's only worth 2 marks. So I'm not anticipating too much is required from me here. And so this is a little bit of a tip to those people who do extension 2, where you learn that if you recognize something like this, underneath the square root you have something of the form a squared minus x squared, then you want to make the substitution x equal to a sine or a cos theta. Okay, but here that's completely unnecessary because this is already a standard form. Okay, this one is quotable. You can just write down that this is going to be an inverse sine. So it's very unnecessary to make this substitution x equal to a sine theta. It brings up a lot of places in which you could make an error, and it's also just completely wasting your own time. Okay, it doesn't say to make a substitution, so you can just use the fact that it's a standard form. It's an inverse trig function. That's something that you learn in extension 1, and so that's what they're assessing here. So this is going to be inverse sine of x on 2, and we're evaluating that between 0 and root 3. Okay, so you probably get 1 mark just for getting the antiderivative correct, and then your next mark is probably going to come from getting the correct final answer, so substituting these in correctly. Inverse sine of root 3 on 2 minus the inverse sine of 0. Now, sine of what gives me root 3 on 2? That would be sine 60 or pi on 3. And then sine of what gives me 0? That would be 0. So my final answer is pi on 3 there. Okay, and that's the end for part F. Now part G is saying by factorizing or otherwise, solve 2 sine cubed x plus 2 sine squared x minus sine x minus 1 equal to 0 for the interval x between 0 and 2 pi. Okay, let's write it down. So we have 2 sine cubed x plus 2 sine squared minus sine minus 1 equal to 0. And then it's always really important when you do a trig equation that you're very aware of what your domain is that you're solving over. Okay, here we're just solving between 0 and 2 pi, essentially 1 revolution. Okay, now it tells us by factorizing or otherwise, but since it suggests factorizing, that's probably the way I'm going to approach this. And I can see quite clearly that we're going to have to factorize using pairs. There's 2 pairs there. Okay, so in my first pair, I can see a common factor of 2 sine squared. I'd be left with a sine x plus 1. And then in my second pair, I'm trying to look for a factor which would produce one of these two factors here. And I can see really the only factor between them is -1. If I factor out a -1, I'm left with sine x plus 1 equal to 0. Okay, you probably don't even have to write that 1 there. You can just write negative of sine x plus 1. But now that's good because I can factor out a sine x plus 1 from each of those. So we get sine x plus 1 multiplied by 2 sine squared minus 1 equal to 0. Okay, now you might be able to write down that sine x straight away is equal to -1, and then plus or minus 1 on root 2. And so here we've got to solve really 3 equations: sine x equal to -1, sine x equal to positive 1 on root 2, and then sine x equal to the -1 on root 2. Now let's deal with sine x equal to -1. This is a boundary case, and personally with boundary cases, I like to do a really quick and rough graph and just read off from the graph what the value should be. So if I do a very quick graph like this, okay, it's a terrible looking sine graph, but it's all I need. I know that this is pi here, this is 2 pi. And I'm looking for when it's equal to -1. There's only one point for -1 there. And I find that it's 3 pi on 2. Cool, so I've got one of my solutions already. I've got x is equal to 3 pi on 2. Now, what does this plus or minus do? Well, if it's positive, we're solving sine equal to positive 1 on root 2. That occurs in the first and second quadrant. If it's negative, it's the same angle, but we're checking what the value would be in the third and the fourth quadrant. So the fact that I've got a plus or minus here means I'm really solving the one equation, but then finding the value in each of the 4 quadrants, first, second, third, and fourth. So what would the reference angle here be? It would be inverse sine of 1 on root 2, which is pi on 4. And then I just need to work out what is pi on 4 equivalent to in each of the next 3 angles, 3 quadrants. So it would be pi minus pi on 4, it would be pi plus pi on 4, and 2 pi minus pi on 4. Okay, and now I just have to work those out and write them. I'm also just going to write them in increasing order. It's a little bit more pleasant on the eye to read when it goes in increasing order. So pi on 4, 3 pi on 4, 5 pi on 4. The next one in increasing order would be 3 pi on 2. And then the final one would be in the fourth quadrant. That's 7 pi on 4. Okay, and so that's our answer for this trig equation. We have 5 solutions here. You would need all 5 of them to get the correct answer, or to get the full marks. Now, our last part of this question, this is part H. The roots of x to the 4 minus 3x plus 6 equal to 0 are alpha, beta, gamma, and delta. What is the value of 1 on alpha plus 1 on beta plus 1 on gamma plus 1 on delta? Okay, let's write down the polynomial. X to the 4 minus 3x plus 6 equal to 0. And we're looking for the sum of the reciprocals of all of these. And before I write that down, the one thing I am going to do is I notice that I have some terms that appear to be missing here. The x cubed term appears to be missing. The x squared term appears to be missing. And this is one of those scenarios where I actually like to physically see that they do exist, but they just have a coefficient of 0. So I'm going to write down here, this is x to the 4 plus 0x cubed plus 0x squared minus 3x plus 6. And the reason I want to do that is because I really want to put it in the form of a x to the 4 plus bx cubed plus cx squared plus dx plus e equal to 0. Because now I want to work out my sum of roots 1 at a time, 2 at a time, 3 at a time, whatever's appropriate in order to help me solve this question. So what I'm looking for is I'm looking for 1 on alpha plus 1 on beta plus 1 on gamma plus 1 on delta. What I'm going to try to do here is make a common denominator. So obviously my common denominator would be alpha, beta, gamma, delta, which by the way is the product of roots. That's one of those things that we can calculate, which is good. So if I make my common denominator here, I would get beta gamma delta plus alpha gamma delta plus alpha beta delta plus alpha beta gamma. And then all of this I would divide by alpha, beta, gamma, delta. And so what I have on top is I have the sum of roots 3 at a time divided by my product of roots in the denominator. So the notation that I like to use, and I've been teaching my classes, is to use this to represent the sum of roots 3 at a time. Now, just because it's alpha, beta, gamma, it doesn't mean we're only summing alpha, beta, gamma. We are summing all of the roots, but we're just taking them 3 at a time. And we're dividing by the product of roots. This capital pi here is a symbol for product, and the product of roots are taken 1 at a time. So it's pi time, or not pi times, it's pi, the product of one root, times all the other roots taken once at a time. Okay, so we need to just work out the numerator and the denominator here, but that's not too bad. I'll write down on the side here, the sum of roots 1 at a time is minus b on a. Even though I don't need it, I'm going to physically write it because I want to keep track of the negative, positive, alternating negative sign as we go down. Sum of roots 2 at a time is c on a. Sum of roots 3 at a time is negative d on a. And then the sum of roots, it's really the sum of roots 4 at a time. The sum of roots 4 at a time, or the product of roots 1 at a time, is e on a. Okay. Now, obviously, we're only interested in these two, and so those are the only ones we're going to calculate. Negative d on a. In this scenario, that's negative 3 on 1, which is, oops, that should be positive 3. And here we've got e on a. That's 6 divided by 1, which is 6. So the sum of roots 3 at a time is 3. The sum of roots, or the product of roots 1 at a time, is 6. And so we get a half as our final answer. So that's the end of part H and the end of question 11.